Yeah, good morning all. Now I am going to explain some more questions on transformers. Okay, in a single phase transformer, the magnitude of leakage reactance is twice of resistance of both primary and secondary. With secondary is short circuited. What is the input power factor? Okay, here secondary is short circuited, whatever it may be. Power factor formula is cos pi is equals to R by Z. Here X is equals to 2 times of resistance. Now see here, cos pi, power factor cos pi is equals to R by Z, where Z is equals to again under root R square plus XL square, that is R by under root R square plus X is equals to 2 times of R, right? If I substitute that value, I will get R by under root 5 R square. In denominator I can take R as common, then if I can take R as outside, then the resultant value will be 1 by root 5 is correct. That means 54th question will be answer is 1 by root 5 is correct. Next, high leakage impedance transformers are used for applications such as, okay, high leakage impedance transformers are used in arc welding. Next, 56th question. Next, 56th question. In an ideal transformer shown in first figure. Okay, now see here what is given. Primary turns ratio is given A is to 1, that is nothing but N1 is to N1 value is A is to 1. Okay, that means transformation ratio K is nothing but N2 by N1, that is K is equals to 1 by A, that is transformation ratio K is equals to 1 by A, that is equals to V2 by V1, that is equals to N2 by N1, that is equals to I1 by I2, right? From that equation, V1 is equals to A into V2. Okay, next I1 by I2 is equals to 1 by A, right? Then I2 is equals to A I1. Okay, from the given options, now see observe the first option, V1 is equals to A V2, I2 is equals to A I1, right? That means first option is correct. But see here minus is given, right? Minus indicates primary current to secondary current, there is a 180 degrees phase displacement. Okay, that is the difference. See here, there is no option which is having I2 is equals to plus A into I1, right? No need to confuse here. Next, similar problem, 57th question. In ideal transformer shown in figure, that means second figure, what is given? N1 is to N2 is equals to 1 is to A. That means transformation ratio K is equals to N2 by N1, right? That is K is equals to A by 1, that is equals to N2 by N1, that is equals to V2 by V1, that is equals to I1 by I2. Okay, if I simplify that equation, I will get, see here 57th question, V2 is equals to AV1, right? Then I2 is equals to I1 by A. V2 is equals to AV1. That means 57th answer will be D is correct. Next, 58th question. When compared with power transformer, a distribution transformer has, this is direct question, low percentage impedance and high I square loss to core loss ratio. That means copper losses should be more. That means 58th question answer is A is correct. Next, 59th question. Following statements are made regarding the open circuit test on a single phase transformer. Okay, now see here from the given options, it is performed on LV side. Okay, always open circuit test conducted on LV side and HV side should be open circuited. That means first point is correct. Okay, it is performed at rated current. Okay, open circuit test means no load current. That means there is no load. That means we didn't apply any rated current. That means second option is not correct. Next, third option, it helps in the calculation of equivalent leakage impedance. That is also not correct. That is calculated in short circuit test. Next, it is performed on HV side. That is also not correct. HV is open circuited. Next, it is performed at rated voltage. That is correct. Next, it gives magnetizing current and core loss. Okay, that means OC test is used to find out the no load currents and no load branch parameters. That means magnetizing current and core loss component of current is nothing but no load branches. That means sixth one is also correct. Next, seventh point, it helps in the determination of voltage regulation. Okay, no, voltage regulation always calculated under loaded condition. Okay, next, last one, it gives turns ratio. That is also correct. That means 1, 5, 6, 8 is correct. That means first option is correct. Next question. Following statements are made regarding the short circuit test on single phase transformer. Okay, remember one point, in case of short circuit test always conducted on HV side. Okay, LV side is replaced by short circuit, then only rated current is flowing on the secondary. That means secondary side or low voltage side. Okay, low voltage side only high current is flowing, right? For that purpose always LV side only short circuited, HV side test is conducted. Okay, on this HV side we need to apply very reduced voltage, that is 5 to 8% of reduced voltage is applied. Okay, that voltage is depends upon the magnitude of short circuited current. Now see the options. First one is HV side is short circuited. That is not correct, right? Next, it is performed at rated current. That means we need to apply rated current on LV side. That means second option is correct. Third option, it gives the core losses. That is not correct. Fourth option, LV side is short circuited. That is correct. Fourth point. Next, it is performed at rated voltage. That is also not correct. It gives ohmic losses on the side instruments. That is also not correct. It helps the calculation of voltage regulation. Voltage regulation always calculated on loaded condition. That means this is also correct. That means 60th question answer will be fourth option is correct. 247. Next, 61st question. A 10 kVA, 400 by 200 volts single phase transformer with 10% leakage impedance draws a steady short circuit line current. Okay, steady short circuit line current is equals to percentage impedance into actual current. Actual current formula is given kVA rating divided by HV voltage. Now see here HV voltage is 400 volts, right? Then steady short circuit current formula will be percentage impedance value is given as 10. Current I is equals to given kVA rating is 10 kVA, that is 10 into 10 to the power 3 divided by HV voltage is 400 volts. Okay, if I simplify that equation, I will get current as 250 amperes. From the given options, third option is correct. Next, 62nd question. While performing the open circuit and short circuit test on a transformer to determine its parameters, okay, the status of low voltage winding and high voltage windings will be such that, okay, now see the options. In OC test, LV is open. That is not correct, right? In OC test, LV side test is conducted, HV is open. That means from the seeing the first point, that is not correct. Next, second point, in OC HV is open. That is correct. LV side test is conducted and HV is open. And in SC LV is shorted. That means second option is correct. 62nd bit. Next, 63rd bit. A multimeter for measuring resistance is connected to one terminal of primary and the other terminal of secondary. The multimeter reading would be, already we know that transformer is a static device which transfer power from one circuit to another circuit. Okay, but there is no electrical connection between primary to secondary, right? That means there is no wire connection between primary to secondary. Okay, that means two windings are magnetically coupled, electrically isolated. Okay, here he is connected one terminal, one measuring device on primary winding, one measuring device is on secondary winding. Then the winding is open circuited, right? Because no electrical connection between primary to secondary. When winding is open circuited, right, the multimeter shows infinite reading. That means 63rd answer will be B is correct. Next, for a given base voltage and base volt amperes, Okay, base volt ampere is nothing but MVA or KVA rating. The per unit leakage impedance of a transformer is X. What will be the per unit leakage impedance of the transformer when the voltage and volt ampere base are both are doubled? Now see here, from this question the formula will be Z per unit new is equals to Z per unit old value is given as X, MVA new by MVA old into kV old square divided by kV new square. Here what is given? KVA rating or MVA rating, and double MVA rating is doubled and KVA rating is also doubled. That means new values are doubled. That is X into 2 by 1 into 1 by new value will be doubled at 2 times of square. That means I will get the answer as X by 2, that is equals to 0.5x is the correct answer. That means 64th answer is A is correct. Next, at 50 Hz operation, a single phase transformer has hysteresis loss of 200 watts and eddy current loss of 100 watts. Its core loss at 60 Hz frequency. Okay, now already we know that hysteresis loss is directly proportional to frequency, eddy current loss is directly proportional to frequency square. Okay, now see the solution here. WH2 by WH1 is equals to F2 by F1. Then WH2 is equals to WH1 into F2 by F1. Okay, that is hysteresis loss will be 240 watts. Similarly, eddy current losses are directly proportional to frequency square. From that equation, WE2 value is 144 watts. Then total iron losses is equals to hysteresis losses plus eddy current losses. That value will be 384 watts. Okay, that means from the given options, which option is correct? 65th question, C is correct. Next, 66th question already solved, same previous question. Okay, that is B is correct. Next, in a transformer, eddy current loss is 100 watts, which is half of the total core loss. If both the thickness of laminations and frequency are increased by 10%, the new core loss would be, core loss is nothing but hysteresis loss and eddy current loss, right? Hysteresis losses are depends upon frequency, eddy current losses are depends upon frequency square and thickness of laminations. Okay, now see here from this equation, WH2 by WH1 is equals to F2 by F1, right? Frequency is increased by 10% means F2 is equals to 1.1 times of F1. Okay, that means hysteresis losses is equals to 110 watts. Similarly, WE2 by WE1 is equals to F2 by F1 whole square into T2 by T1 whole square. Here F2 is equals to 2 times of F1. Thickness also T2 is equals to 2 times of T1. If you simplify this equation, you will get eddy current losses as 146 watts. Okay, then total losses is equals to hysteresis losses plus eddy current losses, that is equals to 110 watts plus 146 watts. Resultant value will be approximately 256 watts. Right, from the given options, 256.41 is the correct answer. That means first answer is correct. Okay, remaining we will see in next class. Okay, thank you all.